This video will help you solve simple problems in discrete random variables. We'll quickly jump into problem number 1. Let capital X be a discrete random variable with the following probability function. Let X takes the value 0, 1, 2, 3, 4 with the corresponding probability of X capital X taking the value small x being K, 3K, 5K, 7K and 9K. Now find question number 1 the value of K, question number 2 the value of the probability that capital X is greater than or equal to 3. Question number 3, the probability that X is less than 2. And 4, probability that 1 less than X less than 4. So we will quickly jump into the solution of it. So how to begin with problem number 1, finding the value of K. Where is the K involved? K is involved in the probability. We have been given with a discrete random variable which has a probability mass function that satisfies two conditions. The first condition being the individual probabilities are always greater than or equal to 0, and the second condition is that when we add all the probabilities, the total probability must be equal to 1. So we make use of this second condition to estimate the value. So what does this say? We know that addition of all the probabilities is equal to 1. So when we add K plus 3K plus 5K plus 9K plus 7K must be equal to 1. 9 plus 1 makes it as 10. 7 plus 3 is 10. So 20 and 25. So 25K equal to 1. So what will be the value of K? K will be 1 by 25. After solving and getting the value of K, what we will have to do is resubstitute back in this probability function. Only then we will be able to estimate the remaining of the probabilities. So now the value taken by X are 0, 1, 2, 3 and 4, and the corresponding probability of X are K. So what is our K? 1 by 25, 3K. So 3 by 25, 5 by 25, 7 by 25 and 9 by 25. So we are done with first subdivision. What is our second subdivision? Second subdivision asks us to find the probability of X greater than or equal to 3. We need to be very careful about the equality and inequality in discrete random variable because it takes only finite number of values. So we'll have to keep in mind that X greater than or equal to A and X strictly greater than A are entirely different. Over here it is inclusive of A and over here you don't include A. So though A is going to be just 1 point, so since it is going to be one of the finite points, it will alter the probability by a greater value. So be careful when you see inequality being present in a discrete random variable. So when X is greater than or equal to 3, you begin with 3, you include 3 and then move on to the values greater than that. What is the number greater than that? 4. So this will be probability of X equal to 3 and X equal to 4. So what will be the probability for this quantity? X equal to 3 has a probability 7 by 25 and X equal to 4 has a probability 9 by 25. So when you add this, you will have it as 16 by 25. Moving on to the third subdivision. The third subdivision asks us about probability of X strictly less than 2. So we want probability of X strictly less than 2. So now looking into the inequality, we know that is 2 inclusive? There is no equal to, so 2 will not be included. So you don't include 2 and you have x less than 2. Less than 2 means you will have to move to the quantities which are lower than that. So what are the quantities lower than that? So this will be probability that x takes the value 1 and x takes the value 0. Notice we are not including 2 because you don't have an equal to sign over here. So now this gives us probability that x takes the value 1 is 3 by 25 and probability that x takes the value 0 is 1 by 25. So that makes it as 4 by 25. Now moving on to the fourth subdivision, what happens over here? We want 1 less than x less than 4. So probability of 1 less than x less than 4. So value between 1 and 4. So is the quantity 1 included over here? No, 1 is not included over here. Is the quantity 4 included over here? No, 4 is also not included over here. So when we talk about the numbers lying in between them, what will be the quantity? So we have this to be equal to probability of x taking the value 2 and probability of x taking the value 3. So these are the two numbers that lie within this range. And now how about the answers? The probability of x equal to 2 is 5 by 25 and x equal to 3 is 7 by 25. So when you add both of them, you will have it to be equal to 12 by 25. Next, we will move on to a second problem. Second problem says that probability that let the random variable take the value 1, 2, 3, 4 in such a way that 2 times probability of x equal to 1 equals 3 times probability of x equal to 2 equals probability that x equal to 3 equals 5 times probability x equal to 4. We will have to find the probability distribution of the random variable x. So now how to go about this statement? When we have the solution, we know that the probability that the random variable x takes the value is 1, 2, 3, 4. So it is discrete in nature. 1, 2, 3, 4. The next thing is I need to find what is going to be the probability taken by these random variables. How can I estimate it? Now, these probabilities that this random variable takes are being given by form of a relation, in form of a ratio. So let me equate this ratio 1 is to 2 is to 3 is to 4, something like that, to the constant called as k. So if I am going to equate this k, they all now lie in a ratio. So now I can compare them. So what happens over here? 2 times probability of x equal to 1 is k. So what can we say about probability that x equal to 1? It will be k by 2. So this will be k by 2. Now compare this with the second ratio. So what will happen over here? 3 times probability that x equal to 2 is equal to k. So probability that x equal to 2 will be k by 3. So this will be k by 3. Next, compare it with the third probability. So k equal to probability of x equal to 3. So probability that x equal to 3 is directly equal to k. And equating it to the fourth ratio, we have 5 times probability of x equal to 4 equal to k. So probability that x equal to 4 will be k by 5. K by 5. So this will be k by 5. Now I need to find the value of k. How to get the value of k? We know that when we add all the probabilities, the total sum is equal to 1. So this gives me k by 2 plus k by 3 plus k by 5 equal to 1. Now how to solve for it? We know the LCM of 2, 3, 5 is going to be 5 3s are 15, 15 2s are 30. So 30 goes into 15 times. So this is going to be 15 plus, let me take k common outside because it is common to all. 3 goes in k 30 10 times. There is denominator 1. So this is going to be 30. And over here it goes 6 times. So 6. So this is equal to k. So we have 15, 10, 30 and 6. When we add it up, 5 plus 6 makes it as 11. 3, 4, 5, 6. So that makes it as 61. So this gives me 61 times of k by 30 equal to 1. So my value of k is 30 divided by 61. So the value of k is 30 by 61. Now try resubstituting it back over here. So this becomes 30 by 61 times of 2, 30 by 61 times of 3, and 30 by 61 directly, and 30 by 61 times of 5. So what will be the final probability of x? This 2 goes over here 15 times, so 15 by 61. 3 goes 10 times, so 10 by 61. This is directly 30 by 61, and this goes 6 times, so it is 6 by 61. So this is the required probability distribution of x. Now moving quickly to the third problem. Let us have a random variable x to be discrete with probability distribution. Probability of x equal to small x is given as kx, where x takes the value 1, 2, 3 and 4. Find the value of k and find probability of 2 less than x less than 4. Now how to get the values? X takes the values 1, 2, 3, 4, and we have been given probability that x takes the value x is by the function kx. So now let us get the value for probability of x. Now when x takes the value, the first value 1, so this is 1, so k times 1, so it is k. When x takes the value 2, it is going to be 2k. When x takes the value 3, it is 3k. And when x takes the value 4, it is 4k. So how to estimate the value of k? We know that summation of all the probabilities is equal to 1, by which we have k plus 2k plus 3k plus 4k will be equal to 1. So this gives me 4, 5, 6, 7, 8, 9, 10. 10k equal to 1. So k equal to 1 by 10. So this can be resubstituted as 1 by 10, 2 by 10, 3 by 10 and 4 by 10. Now that solves the first quantity. Now moving on to the second question. Probability of 2 less than x less than 4. How to estimate this? Where is our 2 here and where is our 4 here? Now again look into the inequality. Do you have a equal to sign here? No. Which means is 2 included? No. 2 is not included. Look over the right hand. It is 4. Do you have a equal to sign here? No. So is 4 included? No. So we don't have 4, but we have only the value that lies between 2 and 4. So what is it? It is the number 3. So now this probability is nothing but probability that x takes the value 3, which is directly given by the quantity over here 3 by 10. So this completes our problem.